A particle p moves along a straight line, and its acceleration when it has a displacement of x meters from O, a fixed point in the line, is of magnitude 8x meters per second squared and directed towards O. Now that part is important because if this is O, if our particle is here and x is positive, then the acceleration will be negative. But if we're over here and x is negative, so that would be negative, the acceleration is this way. So the acceleration is always in the opposite direction to the displacement, and we'll see how that manifests shortly. The velocity of the particle is v meters per second, and initially v is equal to 0 when x is equal to 2. The first thing we want to do is obtain an expression for v squared as a function of x. What we have here is that the acceleration is negative 8x. And that's to do with what we discussed up here. It's in the opposite direction to x. So we can now use v dv dx is equal to negative 8x, or you could use the d dx of a half v squared, and then separate and integrate if you're doing it this way. So we get the integral of v dv is equal to negative 8 times the integral of x dx. And so v squared over 2 would be equal to negative 8x squared over 2 plus a constant. That gives me v squared is equal to a constant, take away 8x squared. We can now use v equals 0 when x equals 2, and that gives us 0 is equal to a, take away 8 times 2 squared. That gives me that a is equal to 32, and so v squared would be equal to 32 minus 8x squared. We now want to find the values of x for which v is 0. So if v is equal to 0, we get that 32 minus 8x squared is equal to 0. That means 8x squared is equal to 32, and therefore x squared is equal to 4, and so x is equal to plus or minus 2 meters. In other words, it's travelling along this line, here's O, and at negative 2 and at 2 it stops. So it travels out this way, and because the acceleration is back towards O, it's going to slow down, stop here, and then it will go back, and then once it passes O, the acceleration would be in this direction, so it slows down and stops at 2. It's an example of simple harmonic motion, which we'll be coming onto. So we now want to find the maximum speed of p. Well, if we look at the expression v squared is equal to 32 minus 8x squared, because this bit is negative, always negative because of the x squared being positive, it should be clear that x equals 0 is going to give us the maximum v, and that would be at the center of motion here. So we have that v squared is equal to 32. Therefore, v would be the square root of 32, which is root 16 root 2. So it's going to be 4 root 2 meters per second.